Hello friends, in this video we are going to continue with the chapter matter. This is part 3. So let's start. In this video we are going to discuss about the evaporation. Let's go. The phenomenon of change of a liquid into vapor at any temperature below its boiling point is called evaporation. Like you will see sea or river, there the water sometimes evaporates, sometimes no, many a times it evaporates. Every time it evaporates, when the sun comes, the heat energy is transferred. Because of this, the heat energy which is coming from the bulk of liquid is taking away the water and converting it into the vapor state. Now let's know how this is happening. Due to the continuous motion of this air, the liquid particles collide with one another. When a liquid is exposed in air, when a liquid is exposed to air, collision between the air particles and the liquid particles take place at surface. During these collisions, some particles of liquid get extra energy and overcome the interparticle force of attraction. These highly energetic particles leave the surface and convert into vapors. Okay, so now let's look some examples based on evaporation. So the first one is the liquid kept in an open vessel. You might have seen in your kitchen also. In an open vessel, the liquid evaporates by itself because the particles of liquid absorb energy from its surrounding. After some time, it is observed that the quantity of liquid is lesser than before. The second example is drying of clothes, which is very common. Wet clothes dry because they pick up energy from their surrounding. Sweating is the third example. During summers, sweat on the skin evaporates by taking energy from the surrounding and body. This causes cooling and lowering of the body temperature. Now, the next is evaporation leads to cooling. Now, let's see how it is happening. As we know that evaporation is a surface phenomenon. In the process of evaporation, the surface particles leave the surface by taking heat energy from the bulk of liquid, and hence the temperature of bulk of liquid decreases, which causes cooling. Now let's look on some examples. So the first example is we will say that why it is always being taught that we should wear cotton clothes in summer. Why should we wear cotton clothes in summer? Let's look. During summer, we perspire more, and cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. Okay, now again, there is an example like water in earth pot gets cool, or water which is kept in the matka gets cool. Why does the water get cooled in an earth pot? An earth pot has small pores in its walls. When water is poured into it, some of it seeps through these pores to its outer surface and evaporates. The heat required for evaporation is taken from the water in the earth pot. As a result, the water in an earth pot gets cooled down. Okay. Next, one more example is there. Why do we feel relief under a fan when we perspire? So it has a simple answer. The air from the fan causes rapid evaporation of sweat. During evaporation, the sweat takes away from heat from the body. Okay, as a result, we feel relief under a fan. I hope you understood. Next is the factors which affect the evaporation. Okay, so the first factor which affect is surface area. Okay, surface area of a liquid. So let's look. Evaporation is a surface phenomenon, we know that. But an increase in the surface area increases the rate of evaporation. Why? Because more surface area provides more space for large number of particles to get evaporated. That is why An unfolded cloth dries faster than a folded one. Okay. Second example is the or second factor, temperature. Higher the temperature, higher will be the number of active particles with the high kinetic energy, and hence more evaporation will be there. Third is the humidity. Humidity, like water vapor present in air, causes humidity. Okay, humidity decreases the rate of evaporation of water. So wet clothes take a longer time to dry in the humid air, but they dry faster in the dry air. That is why we call it one by humidity. Okay, because it is not directly proportional to evaporation, it is indirectly proportional to evaporation. Okay, and the last one is the wind speed. During evaporation, the air around the wet object becomes saturated with water vapor. As a result, the rate of evaporation becomes slower, but with an increase in the speed of wind, the moist air is replaced by dry air. This results in faster rate of evaporation. Okay, so this was all in this video. For the further videos, keep tracking.